Virginia University College of Law. This is truly a thrilling day for me as the Dean of the College of Law, and I want to just spend 1 minute and tell you why. And that's because there are several professors who've been here at the law school for a long time, even longer than I have been, who have cared about these issues like climate change, sustainable development, environmental protection for their entire careers. For example, many of you know Professor Pat McGinley, who's been leading this effort forward for a very long time. But recently, we've actually been able to do more than ever before. And we've been able to bring some new professors here who also care deeply about these issues. Professor Allison Peck, for example, who is our natural resources guru and our sustainable agriculture professor. And I care very deeply about these issues as well, and so we started a Center for Energy and Sustainable Development when I became the dean, and we also, with Clean Water Act settlements, were able to start a land use and sustainable development clinical program. And for our Center for Energy and Sustainable Development, we've been able to add 2 professors, Professor Jamie Van Nostrand and Professor Joshua Fershey, who is over here. Now, is Jamie here? Wave widely, no. Oh, there he is. Jamie just walked in. So there's our Center for Energy and Sustainable Development. And Kat Garvey is here, who's the director of our Land Use and Sustainable Development Clinical Program. And the reason I'm taking a few minutes of your time to point all of this out is that being able to have these amazing professionals here and to add to our curriculum and also to create experiential opportunities and service opportunities, not only here in West Virginia, but internationally, is putting us on the map on these issues. So it's a very exciting time for us, and therefore extremely appropriate that we would have such a highly esteemed guest today. And I'm actually going to turn over the introduction of our guest to Professor Michael Blumenthal. Thank you all so much for being here today.
Thank you. I'm glad so many people have made it. I wanted to thank Dean McConnell and Dean LaFaso and the Environmental Law Society and the irreplaceable Margaret Obuck. You're all irreplaceable also, but we know who really is. And I was saying to Tom Lovejoy on the way over that we're so hospitable here in West Virginia that we even created some climate change overnight just so he would feel at home. We were also talking, Tom mentioned in the elevator that he had once had to introduce the Dalai Lama at the Smithsonian, and he got up and he said, well, how do you introduce the Dalai Lama? And he said, ladies and gentlemen, the Dalai Lama, which is what I should do today, ladies and gentlemen, Tom Lovejoy, but I'm going to say a little and cut what I was going to say. I was originally going to say that Tom Lovejoy is one of the best people on the planet, and then I realized I didn't really know enough about the control group to make such a grandiose statement, but that I could simply change the preposition and say something true, which is that Tom Lovejoy is one of the best people for the planet. Some of you, or many of you, may have read or watched Professor academics, we want to make President Obama's inaugural speech, and may remember that he said the following: we will respond to the threat of climate change knowing that the failure to do so would betray our children and future generations. Some may still deny the overwhelming judgment of science, but none can avoid the devastating impact of raging fires and crippling drought and more powerful storms. Supposedly 85% of the American people agree with the president, and the other 15% are in Congress. But if any of those 15% have straggled into this room, I think you're about to change your mind. I've known Tom Lovejoy for about 100 years, 1977 to be precise. I met him when I was working on a piece on tropical rainforests for Time Life, and I knew about as much about tropical rainforests as I did about tightrope walking. So I called a friend at the Smithsonian and I said, can you recommend somebody who knows something about tropical rainforests? And he said, well, there's only one person, Tom Lovejoy. and indeed there was, so that now a boy who grew up in Manhattan, I know what an epiphytic plant is, and a liana, and a bromeliad, and a blue morpho butterfly, and a hoatzin, and all kinds of things I wouldn't have known but for Tom. In fact, ever since I've met him, I've wanted to be Tom Lovejoy, but it was a little too late. And so here I am introducing him, which is almost as good. I'm not going to bother listing, since it would take the whole hour, all of the remarkable things on Tom's resume, one of which is, for example, that he founded the program Nature, which we forced him to miss last night by taking him to dinner, hosted by his friend David Attenborough. In 1978, he conceived the idea for a long-term study of forest fragmentation in the Amazon, known as the Minimum Critical Size of Ecosystems Project, which is, to this day, I think, the largest program ever the largest experiment in landscape ecology. He coined the term biological diversity. I could go on and on and on and on. But I will say two things that I particularly admire about Tom and his career. One is something that made me think of the Danish philosopher Kierkegaard's famous statement that purity of heart is to will one thing, or more contemporarily, Rick Warren has described as the purpose-driven life. I think Tom Lovejoy's career really testifies to that fact. For over 40 years, he's made a heroic effort to sustain the vitality and health of the planet for our children and our children's children. And the second, which is probably a strange thing for somebody who's supposed to be a poet to say, is that Tom is no romantic, maybe in his private life, I don't know, but at least in his public and professional life. He sees the world, to paraphrase something Robert Kennedy said, not only for what it could be, but for what it is. He's somebody who's able to negotiate with presidents of countries, CEOs, heads of lumber companies, bureaucrats in Brazil, anyone who's willing to talk and listen. And I think in that sense, his career provides a terrific model for our students here and for the current political climate in this country. And to all that I would add, he's also a terrific guy. So please help me welcome one of the best people on the planet and for the planet, Tom Lovejoy.
Well, how do you say thank you to that? You say thank you. Thank you very much. So in the time allotted to me, I want to cover a lot. So I'm going to try and go through this fairly rapidly, but what I want to do is give you some sense of how climate change is currently having an impact on biological diversity and nature around this planet, a bit of a look ahead of where it might go, and then finally how, in fact, managing the entire planet as the living and physical system that it is actually might help us both reduce some of the climate change that otherwise would occur and make it more resilient in the face of the climate change that's coming. So, back in June, there was the 20th anniversary international conference negotiations in Rio de Janeiro, 20 years after the Earth Summit. The international negotiations were actually quite disappointing, but a lot of good things happened both in the private sector side at lower levels of government and nations and, of course, in civil society. And one of the differences going into it compared to 20 years before was this sort of capsule analysis of the environmental challenges faced by the planet, produced by the Stockholm Environment Institute in 2009. And the notion was that there are some boundaries in terms of how the planet works, and in at least 3 instances where we actually have data, we clearly have transgressed those, and those sort of represent the major challenges environmentally going forward. So the one on the right, the nitrogen cycle, is where there's about double the natural level of biologically active nitrogen now available on the planet. It's creating dead zones in the Gulf of Mexico and around the world. I think they got that one pretty close to correct. The one at the top, climate change, I think, in fact, is underestimated. I don't think they factored in the impact on the natural world sufficiently, and I'm trying to make that case in the course of the talk. And then the one on the lower left, the biological diversity, is the one that shows the greatest transgression, and that's not surprising at all, because in the end there's nothing that we call an environmental problem that doesn't affect living systems. So biological diversity integrates all of that, and even though it's obvious when you destroy habitat that you're affecting biodiversity, all the other kinds of environmental transgressions affect it as well. So that's sort of the general framework. And then I always think it's important to start with the Swedish scientist Arrhenius, who in 1896 asked an extremely important question, which is, why is the Earth a habitable temperature for humans and other forms of life? Why isn't it too cold? And the answer in that classic paper of 1896 was the presence of greenhouse gases, like carbon dioxide, because otherwise, in fact, the planet would be much too cold to support life on Earth. What Arrhenius would not have known was anything about the detailed history of the temperature of the planet over, say, the last couple 100,000 years, and in particular, as you see on the upper right here, that the last 10,000 years have been a period of unusual stability in the global climate. And that 10,000 years encompasses all recorded human history, significant portion of unrecorded human history, the origins of agriculture, the origins of human settlements. Basically, the point is the entire human enterprise is based on the assumption of a stable climate. And during that same 10,000 years, all ecosystems have been adapting to a stable climate. And of course, that's now changing rapidly, and the Earth's climate system is responding to it. So the planet, on average, is about 0.8 plus degrees warmer than in pre-industrial times. And we're rapidly contributing more greenhouse gases to that picture at a rate greater than the worst-case scenario in the last report of the Intergovernmental Panel on Climate Change. So this has already had impacts on nature, which are visible and measurable all over the place. So one of the most dramatic, of course, involves the ice on the Arctic Ocean, which floats on the Arctic Ocean. So when it does melt, it's like an ice cube in a glass. It doesn't raise sea level rise. But as you can see in this depiction of the annual expansion and retreat of the sea ice in the Arctic Ocean, it's actually been declining at a rate that's quite rapid, and indeed more rapid than predicted. So probably by 2015 to 2020, we will have the first summer in which there will be a moment in which there will be no ice floating in the Arctic Ocean. So lakes are freezing later in the autumn. The ice is breaking up earlier in the spring. Glaciers are in retreat in most parts of the world. So soon Glacier National Park will be that only in name. And in the tropics, where there are glaciers on top of high mountains like Kilimanjaro or Kinabalu in Borneo, all tropical glaciers are retreating at a rate that they will be gone in less than 15 years. So this is all about physical nature, and in particular the liquid and solid states of water. We're also seeing sea level rise. So this is somewhat out of date, in fact, because sea level rise at the time of Hurricane Sandy and hitting New York, sea level rise there was already about half a meter higher than in pre-industrial times. And just going back to that for a second, most of sea level rise initially was just about the thermal expansion of water. Just takes more space when the temperature is higher. But that now has had serious contributions from glacial melt on land, including up in Greenland. So if you go to some place like the Blackwater National Wildlife Refuge on the eastern shore of Maryland, because of a combination of sea level rise and natural subsidence of the land, basically it's well on its way to becoming a marine refuge. And there is the considerable probability, I won't say certainty yet, but it certainly seems to be headed that way, that all the extra energy in the oceans and elsewhere is contributing to greater frequency of more intense tropical storms. There's absolutely no question at all about the increase of the incidence of wildfire in the American West. It's drier, it's warmer. We see those fires on television or in the newspapers almost on an annual basis. So much for the physical impacts that one can see around the world. What about the biology? And what we're seeing is plant species changing their annual cycles. So lilacs are blooming earlier in New England. A whole series of plant species bloom earlier at the Royal Botanic Gardens in Kew outside of London. I'm sure there are records of this sort here in the state of West Virginia. And it's not just plants that are changing their annual cycles, animals are also. So tree swallows are migrating earlier, nesting earlier, laying eggs earlier. There are even 2 species of birds in North America which have ceased to migrate as a consequence. So in addition, we are seeing in many parts of the world species actually changing where they occur geographically. So this is one of the 2 best-known species of butterflies in North America, the Edith's checker spot, and it is clearly moving northward and upward in altitude in response to climate change. Similar kinds of things have been recorded in Europe. And on Earth Day, when I had the privilege to be out in Yosemite Valley, I learned that the snow in the Sierra no longer falls down to 2,200 feet above sea level. It only goes to about 3,500 feet above sea level, and that has actually resulted in the dieback of ponderosa pine in that altitudinal belt because it depends on snow in winter as part of its natural history. So Joshua trees are moving out of Joshua Tree National Park. So nature is on the move, and the National Arbor Day Foundation, which one can hardly characterize as some wild-eyed environmental terrorist organization, but it's just about people who like to plant trees, literally found it necessary to produce a new hardiness zone map to guide its tree-loving members as to which species they could successfully hope to grow where they happen to live. So the changes are not only in the land, they're also in the oceans. So plankton species are changing their distributions, fish species are changing their distributions. In the Chesapeake Bay, the great estuary on the east coast of North America, the eelgrass communities are very important, highly productive and diverse communities. It turns out eelgrass is very temperature sensitive. won't grow successfully above a certain level of temperature. So the southern boundary of the eelgrass communities in the Chesapeake Bay has been moving northward year after year. And we're seeing changes not just in sort of the Arctic region or the temperate region, we're also seeing them in the tropics. And here we're looking at the legendary cloud forest of Monteverde in Costa Rica. Here the change is less about temperature than precipitation, and what is happening is that clouds are now forming more frequently at higher altitudes than in the past, literally forming above the cloud forest. And since the cloud forest depends for about 98% of its moisture on condensation from the clouds, this is a very serious change for one of these very diverse and rich tropical ecosystems. We're also seeing what are known as decoupling events, where two events in nature have been closely timed, but one happens to use a temperature cue and the other uses a daylight cue, and those are now coming apart. So it is now more and more possible to see snowshoe hares in their brilliant white winter pelage, no longer on snowy backgrounds, but on ones of emerging vegetation, which of course makes them very vulnerable to predation. Another example is this seabird, the guillemot. It nests, among other places, on the north shore of Alaska, and its biology is to fly to the edge of the sea ice, and there it feeds on the Arctic cod, which occurs mostly there, and then they bring it back to the nesting colony to feed their chicks. Well, that's become a longer and longer journey to go every year, and finally at least one or two of these nesting colonies have failed as a consequence. So this slide, for which I would give really bad marks to any of my students, is basically to make the point that what I've been telling you about is no longer a matter of individual example or anecdote. It is statistically robust that nature is on the move and changing in response to climate change almost anywhere in the world you look. But so far, those are really relatively minor ripples in the natural fabric of the planet I've been talking about. The more important question is, what does it look like looking ahead? And, you know, the bottom line is it looks pretty disturbing looking ahead, but it doesn't necessarily have to turn out that way. So when you know the biology of a species pretty well, like the sugar maple, you can project where that species would find favorable conditions in the future. So if you double pre-industrial levels of carbon dioxide, the distribution, which currently is essentially in the northeastern United States, it would mean that if you like autumn foliage or maple sugar or maple syrup, you're going to have to go to Canada. And all 5 of the major computer models show that. Similar kinds of projections have been made looking at tree species in Europe. And so we're talking here not just about issues of temperature change, it's also about precipitation and moisture. And so we are seeing situations in which that then gets combined with other stresses caused by humans on the environment. So greater frequency of more intense drought in West Africa combined with land use changes have literally shrunk the size of Lake Chad to 5% of its original extent. So freshwater species are vulnerable, especially cold water species like trout. And species which live in high places, like this little cute relative of the rabbits, the pika, species that live in high places which will be moving upward like the checker spot butterfly eventually come to a point where there is no further up to go. And so even though the pike has yet to be listed as an endangered species, since it lives in isolated colonies in different parts of the Rocky Mountains, they are in fact emblematic of high-altitude species being vulnerable, especially vulnerable to climate change. So this is going to take you through a look at that kind of stuff involving mammals and bird species unique to the rainforests of northeastern Australia, Queensland. The intensity of the red is how many species you actually have. As you can see, as the climate warms, fewer and fewer of those species which only occur there will be able to survive. Sea level rise, of course, presents a challenge for species that live along the coast. Some will be able to adjust to it more easily than others. But island species as a group will be particularly vulnerable. And it won't be just low islands like the key deer, which basically will go under the rising seas. It will also be islands which have a lot of altitude, but the climate will change, and it will be very hard for those species to actually track their conditions. So high-altitude species and island species will be, as two groups, among the first to really be seriously affected. And of course, those that have natural histories linked to ice, like the polar bear, which is sort of the poster child for all of this, are particularly vulnerable. So there are complications about what climate change means for the natural world as you go further along the trajectory of climate change. And one of them is that we have systematically changed the landscape in most parts of the world in which we live from something which is akin to continuous natural habitat to one in which nature survives in fragments in human-dominated landscapes. And that occurs almost anywhere in the world you look. And what it basically does is it sets up an obstacle course. So changing climate is not new in the history of life on Earth. Glaciers came and went, species moved back and forth, almost none were lost as far as we can tell. But the big difference between then and today is this obstacle course we have created in our landscapes. And this one is easy to fix. And that's already happening here and there, which is just systematically trying to put natural connections back in the landscape, make it easier for the species to move around. And very often you get additional benefits for it. So if you connect them using natural vegetation along watercourses, you in fact are improving the water quality, preventing soil erosion, getting into streams and rivers, and actually improving the fishing. So that one can deal with. But the next one is harder because we know, looking at the past, that ecosystems, biological communities, don't actually move as a unit. It's the individual species that move, each at their own rate in their own direction. So here we're looking at what happened after the last glacier retreated in Europe. We're looking at 3 mammal species, 2 tree species, and 1 insect species, and there is no common pattern. So basically, with increasing amounts of climate change, we will begin to get to a phenomenon where the individual species will be moving to such an extent that the ecosystems we know will unravel and the surviving species will assemble into ecosystems which are pretty hard to imagine in advance. So the bottom line here is the more climate change, the harder it is to manage it in terms of both human well-being and the state of nature. An additional point is that even though all the computer models are linear and gradual, we know, in fact, the climate does not work that way. So in geologic time, we know that This current, known as the global conveyor belt, which moves heat around the globe, has been known to shut down. But we're already seeing abrupt change in ecosystems. And one of the great examples are the coniferous forests of western North America. So anybody who's driven from Denver Airport to Vail, for example, knows that 70% of the coniferous trees are dead. And what's going on is that longer summers and milder winters are tipping the balance in favor of native bark beetles to the point where there's massive coniferous tree mortality from Alaska all the way down to southern Colorado. And here we're looking at British Columbia starting in the 1960s, where at best you can see a few little red pinpricks at the beginning of the outbreaks, and then winter comes along and slams them back. But as time goes on, as the summers are longer and the winters are milder, the beetles get the upper hand, and even after a severe winter in '85, they come back pretty quickly. So that is an abrupt change in ecosystems, and there's some others that we're seeing around the world, and that's only at 0.8 degrees. So that's the point I really want to be making here, is that we're on the threshold of sort of major abrupt changes in ecosystems, and we're seeing that in tropical coral reefs, which all look like this when I was in graduate school, beautiful, technicolor, diverse, highly productive ecosystems, and it turns out they're very vulnerable to just a little bit of increase in water temperature. And that causes the basic partnership of a reef between an alga and a coral animal to break down. And the coral animal expels the alga, and you get what are known as bleaching events. And the whole thing goes black and white, and the diversity and productivity and the benefit to the 1/12 of humanity that depend on coral reefs all crashes. So there's a lot of abrupt change to worry about, and we're seeing change at even greater scales. And one of these involves this pattern of how moisture moves around the world. This is hour by hour for a whole year. I won't take you through the whole year. But on the right hand, you see moisture coming off the tropical Atlantic, entering the Amazon basin, and then it seems to keep being generated in the basin. And that, in fact, is true. The Amazon basin has a hydrological cycle, which I can detail for you some other time, that literally makes half the rain in the Amazon basin. Well, that has begun to show signs of breaking down. So in 2005, it's the greatest recorded drought in the recorded history of the Amazon, repeated again in 2010. So I think we're unfortunately seeing previews of possible dieback in the southern and eastern Amazon, and that would be a huge hit to biological diversity. It would be a huge amount of carbon going up into the atmosphere, creating additional climate change, and obviously a huge hit for the people of that region who depend on the tropical forests for their way of life. So to sum up here, in climate change, we're sort of getting to the point where we're playing close to some critical thresholds in the Earth system, ones that we really don't understand very well. But I think any sensible person would agree that we don't want to find out how they work by triggering these threshold changes. So an additional system change sort of emerged in 2005. Most of us should have seen it coming. I certainly didn't. It turns out that of that excess CO2 already in the atmosphere, a significant portion gets absorbed by the oceans. Climatologists are always considered that a good thing, because otherwise we would have had more CO2 and more climate change. But in fact, some of it turns into carbonic acid. So the oceans today are a tenth of a pH unit more acid than in pre-industrial times, which doesn't sound like very much, but it's an exponential scale, so that's like 30% more acid. And beyond just the shock of thinking that we could change a physical parameter of 2/3 of the planet so easily without even knowing we were doing it, what else does it actually mean? Well, there are tens of thousands of species that live in marine environments that build skeletons and shells from calcium carbonate. And the carbonate equilibrium is very dependent on temperature and on pH. And so the more acid it is, the harder it is for these organisms to actually build their shells. So we've already seen effects in the oyster beds in the northwest of the United States, and we're seeing it at the base of food chains, such as represented here by this tiny little organism, which is literally a teeny snail in which the foot on which a snail normally slides has been modified into little flapping wings, which enable it to stay up in the water column. So these sea butterflies are at the base of the food chain in the North Atlantic and off Alaska, and they are already showing effects from the acidity of the water. So the impacts of acidification of the oceans are actually quite widespread. So I'm going to take you through this very quickly. Just look at the graph at the top. It's basically making the point as that we add CO2 to the atmosphere and make the oceans more acidic, it becomes harder and harder for tropical coral reefs to actually build their architecture. So that basically leads me to the main conclusion, one of two main conclusions here, which is that thinking about a world that is 450 parts per million higher, or 450 parts per million concentration of CO2, 2 degrees plus, is really too much for biological systems. We know it's too much for ice systems, but it's clearly a world without tropical coral reefs and a lot of other parts of the biology of the planet. And just as a no-brainer, we know that the last time the Earth was 2 degrees warmer, sea level was 4 to 6 meters higher, maybe 8 meters higher. I mean, in a way, what more do you need to know? And with a huge concentration of humanity around coasts and a whole bunch of small island states, it doesn't make a lot of sense to go there. So the Royal Society has concluded that you probably should, instead of 450 parts per million, be looking at something like 350 parts per million. So that is a number that a number of us are now agreeing is where we should try and limit climate change. The problem is that we're already in excess of 390 parts per million. The good news is it takes a long time before that increased concentration of CO2 actually traps enough heat to translate into climate change. So the question becomes, is there some kind of way that we could actually pull CO2 out of the atmosphere? This graph basically shows that at current emissions, we would have to peak in 2016 if we wanted to stop at 2 degrees. So that doesn't sound like a very pretty picture, and as I like to say, what should we do? All go to the nearest bar and never show our faces again? Well, there is some good news here. So now Dr. Planet here has made the diagnosis, and he's trying to figure out what to prescribe. And there are a bunch of things you do, revising conservation strategies. So you put connections back into the landscape. You try and remove other stresses on the environments to avoid negative synergies. There's a huge energy agenda, which I'm not going to go into, which I know gets talked about all the time in West Virginia. But there is this other piece of it that's not so well known, which is there is a major chunk of the excess CO2 in the atmosphere that actually came from 3 centuries of destruction of natural ecosystems. And this is the way the annual sort of equation works. Like 1.5 gigatons of carbon from destruction of tropical forests and other ecosystems, about 5 times as much from fossil fuels, ancient ecosystems, and it goes into the atmosphere, the land, and the oceans. How could we play with that equation to maybe even change the direction of one of those arrows? And because these greenhouse gases stay in the atmosphere for a long period of time, that's both a problem but also the opportunity to pull them out before they have raised global temperature. So I think what we really need to wake up to as a global society is the need to lower atmospheric concentrations of CO2. And one of the major ways you can do that is with ecosystem restoration at a planetary scale. And lo and behold, twice in the history of life on Earth, there were screamingly high levels of CO2 in the atmosphere, brought down to pre-industrial levels by biological action. And the first was when green plants first emerged onto land, and the second time was when modern flowering plants came into existence, doing it all more efficiently. So we can do something with this excess CO2 that has come from ecosystem destruction. This is sort of a diagram, which I don't have time to really go into, but the only real number there are the ones on the left. So 280 parts per million was pre-industrial, 350 is what I've been talking about as safe, and 200 or 390 is where it was when this was done. But probably exaggerated, but nonetheless quite real, is the amount of carbon you could pull out of the atmosphere through ecosystem restoration. So that means a lot of reforestation. It means modification of the ways we manage forests. It involves restoration of grasslands and grazing lands. And what do you get when you do that? You get better grazing. And it also involves changing the way in which we manage our agricultural ecosystems. So instead of leaking carbon, they accumulate carbon. And what do you get when you do that? You get increased soil fertility. So as we look ahead, both at the climate change challenge, but also the need to feed at least another 2 billion more people in the world, healthy ecosystems become ever more critical. And so in the end, I think one of the things we need to be embracing enthusiastically is actually managing the living planet as a living system and restoring its ecological capacity, removing some of that potential climate change that otherwise would have serious impact, and essentially use the living planet to regreen the emerald planet and make the planet more habitable. Thank you very much.
Thank you. That was very interesting, to say the least. Are there technologies that you think are promising now for this regreening of the planet that you're talking about?
You know, it's actually, on one level, it's not that hard. And nature is sort of abandoned. Nature's half acre will turn back into something closer to the original ecosystem as if most of the species are around. and if the soil hasn't been too stressed or compacted or something like that. You can hasten it, by actually planting some of the trees that otherwise come along more slowly. So there's sort of an inherent vibrancy of life on Earth, as long as it still exists, right, that is very much our ally in all of this.
Thank you.
Hi. Thanks for joining us today. I was wondering if you have studied or have any recommendations when we start to look at developed countries versus developing countries, and maybe how deforestation is playing a part there, especially in developing areas of the world.
So in the 20th century and into this one, the majority of the deforestation actually has been in developing countries, and particularly in tropical countries. And that's been an issue in itself for a very long time. And it's always complex because in certain instances people see the forest as an obstacle to progress. So there are some agricultural interests in Brazil who only can see increasing productivity by cutting more forest, which in fact is not the case. They have a really fine agricultural research national institute, which has basically figured out that you could increase the productivity of cattle raising in the area of deforestation by a factor of 4. Right? So you literally could do reforestation in that region and increase cattle production. It's not a zero-sum game. And because, in that instance, some of the moisture for agro-industry south of the Amazon comes from the Amazon, that's something that they're beginning to realize they have a big stake in.
Thanks.
Thanks so much, Tom. I realize from what you said that this is obviously a global and international problem, but in your travels, are there countries or programs in some isolation perhaps that serve as models for this kind of
Yeah, so
change
the
in
interesting thing is if you actually get outside of the bubble of the United States, you find first that climate change is much more publicly embraced, not only in terms of public consciousness, but in terms of government programs. And so there are literally dozens of things that go on in any given year around the world which are sources of hope. And Costa Rica is a really interesting country. It now has recovered about 25% of its forest cover that wasn't there 40 years ago. It has 25% of its land cover in protected areas. And Costa Rica is always an interesting country because they tend to experiment and be in the forefront, and my experience has always been, Costa Rica does something and people will say, oh, well, it's a special case, it's Costa Rica, and then 5 years later everybody else is doing it. It's very interesting. But a country which is really interesting to follow from this point of view is Brazil. Our big neighbor to the south, which we should pay more attention to. I'll give you an extraordinary statistic. So when I first set foot in the Amazon in 1965, there was one road in an area equivalent to the 48 states. Now there are 100 kilometers of roads in the Amazon. And the population has grown from 3 million to something like 30 to 40 million. Nobody knows exactly. and you'll periodically see some story about some environmental mess in the Brazilian Amazon. Well, in fact, Brazil has now, like 5 or 6 years running, reduced the deforestation rate dramatically. It has built up a cadre of scientists and government programs that are world-class. And also in 1965, there was one demarcated indigenous area in the Brazilian Amazon, one national forest, no national park. There was one national park in one of the other Amazon countries. Today, more than 52% of the Brazilian Amazon is under some form of protection. It's quite remarkable. We never would have dared to dream that that would be possible. And now they're seriously looking at reforestation in the arc of destruction in the south and east of the Amazon. So there's lots of good news out there. It just isn't quite enough yet. So we just need to fan those flames, right?
Previously, when I've seen presentations showing the state of the planet and the amount of carbon in the air, presenters have offered renewable energy and energy efficiency as the solution. And I just wondered if you could comment on regreening, and is that a substitute for some of those efforts, or just
No,
that has to be done?
Good question, and I should have made it clearer. This is no substitute for a really aggressive and creative energy transformation agenda. And among other things, I mean, given the rate at which fossil fuel emissions are going, I think we need to find ways to actually pull CO2 out of the atmosphere that are non-biological. So we're going to be needing to do all of the above. Yes?
Hi. I was just curious on your opinion as, wildlife managers or as biologists. All of this information is great, but how do we advocate for our work as being important in this, especially in this country, since it's, a political issue here?
So all of those kinds of activities are central to a better future. And if I was giving a biodiversity talk as opposed to this one, I would have ended up by saying that our best ally in all of this is nature itself, not in the way I just talked about it, although that's hugely important, but because if people just can open their eyes and ears for a moment to how extraordinarily wondrous nature is, it can be transformational. And I'm sure you've all seen young people just all of a sudden they get it, right? I love to tell a story of John Bartram, who was an illiterate Pennsylvania farmer in the early part of, or the mid part of the 18th century. And one day, I don't know how old he was, probably 20s or something, he's out plowing and he decides to give the mule a rest, and he just, his gaze just falls upon some kind of composite flower, daisy kind of flower. And it just, they didn't have the phrase in the 18th century, but it blew his mind, right? So he decided that he wanted to be a botanist, which meant that he had to become literate. It meant that he had to learn Latin. The whole science was conducted in Latin. And with Benjamin Franklin's help, he ended up being royal botanist for the colonies. And I think that potential exists in every single human being, and we just need to create more of those opportunities. So, yes?
Dr. Lovejoy, in listening to your presentation and watching the various slides, the terms fragmentation of ecosystems and impact on diversity are a theme of what you've been talking about here. Here in West Virginia, there's been an ongoing debate for a decade about coal mining, its impact on the economy, and also its impact on the environment. And now, more recently, with more global recognition of climate change as a overarching concern, this debate goes on here in West Virginia. One side says West Virginia is there's a war on coal and coal miners in the coal industry, and others say it's ground zero for climate change. Large-scale surface mining, also called mountaintop removal mining, is going on in central Appalachia. And interestingly, and I don't know whether you followed this or looked specifically at central Appalachia, but after the first deforestation, the first round of deforestation, we've got a very extremely diverse deciduous forest that now is being impacted by this large-scale surface mining. And I'm wondering if you have any comments that will help those in West Virginia struggling with this issue of jobs, economy versus environment.
So how do I answer that? Well, first of all, I mean, as I look at the economics of coal today, it's not a pretty picture. It just isn't. It may be rescuable if the coal was exported, but running it against gas, it's in a losing position. At the same time, as far as I'm concerned, you can burn as much fossil fuel as you want as long as CO2 doesn't come out of the chimney, right? And that's not such a silly thing to say, because the technology to pull it out in some inert form is not too far off. So in a way, if we can set those things aside, the issue is how it's mined and what it means to the ecology of the region. And I only have impressions that it's really bad. I mean, I've never done my homework on it. But what it means for natural water courses, get filled up with all that stuff, it seems to me inappropriate is probably a really weak word to use, but it doesn't seem like a sensible thing to do. So if I was thinking about the future of the economy of the state of West Virginia, I'd be looking at some other options other than what's on the table right now. Coal may be around for a while, particularly if it gets into the export stream, but there have to be all kinds of other possibilities, and I just don't know enough to suggest them.
Thank you for being here today. As people have alluded to, it's certainly climate change is a very contentious issue politically here. But as a global industrial and technological leader, what steps do you think the United States needs to take, sort of in a global sense, to sort of spur on change? I know there have been efforts, but here in the United States, I believe we didn't sign the Kyoto Protocol and whatnot. So, just what steps do you think?
Yeah, so there are a whole bunch of things one can sort of do through an economic lens, like a carbon tax, which would really shift how people used energy, and could be done in a way that, in fact, it would be no net increase in taxes. So one of my classmates in college is just about Bill Nordhaus, who's a very prominent economist, is just about to have a book come out in which he makes that case really strongly. But I think there also needs to be a lot of, intense research into new possibilities for economic growth that are less resource intensive. I'm going way beyond, what's going on right here with coal. I think that's the future. New economic ways of bringing the values of nature into how decisions are made, and investment in new forms of growth which are much less resource intensive.
Hi. Thank you again for being here. My question is, a group of scientists in, I believe, Arizona created a method of synthesizing chemicals to create artificial clouds that decreased temperatures in the desert areas that saw major temperature increases as a result of climate change, and also increased precipitation. Does this sound like a viable form of preventing global temperature changes, or should we avoid adding chemicals to the atmosphere at any cost?
So you asked a really good question. And, what terrifies me is that there'll be some calamity that has an even greater impact than Hurricane Sandy that will sort of tip everything into a panic mode. Oh, we got to do something, and it will immediately get into geoengineering schemes. How can you actually change the temperature of the planet so that it doesn't get warmer? And I have pretty strong views about most of them, not all of them. And my view is if you're only addressing temperature, you're only addressing a symptom, you're not addressing the cause. So it does nothing for the oceans and acidification. And most of these are global scale kinds of things to do, which means that whatever their downsides are, they're going to be global in scale too. So having said that, I'm open to a little experimentation, so ephemeral puffs of sulfates up in the Arctic region to see if we can slow down the warming up there while we try and get the whole thing under control. And there are things you can do sort of around the margin which do add up, like painting all the rooftops in the world white. So it's really important, I think, to understand how the whole system works before you start designing some of the solutions.
Thank you.
Wow.
Thank you so much for being here and sharing all of this with us. I actually have a very focused question, and you can answer it in part now, and then we can talk about it later. But I'd like to hear the preliminary answer, and I'd love the people in the audience to hear it. And that is the university, and particularly law school and our College of Agriculture, our College of Engineering, Eberly Biology, Geology. We have all been putting our heads together and putting resources toward trying to be a place where we can actually have a dialogue about energy and sustainable development, about how to continue to live the kind of lifestyles that we live, which may not be possible, or at least expand of this minimal, wonderful, comfortable lifestyle we have to developing nations, at the same time that we protect the planet and allow for sustainable development. We take that very, very seriously. We're trying to position ourselves in a way that we can actually be an important voice in this conversation. So I'd like to know what you see missing at universities that we could contribute, and what you think we might want to do differently than what we're doing.
What is missing? By the way, there's a great thing you can get to online called What is Missing, and it's Maya Lin's last memorial. It's a cyber memorial, and what is missing are all the species that no longer are with us. And there's going to be a whole section on how can we move towards a more sustainable existence on the planet, just starting. So let me say some things that actually go beyond the university but come back. So I think the idea that 2 degrees is actually too much really needs to get out there. And most of the people running around in these international negotiations actually don't have a clue. And it's too dominated by physical scientists, not all of whom are bad this way, but a lot of them just, they don't have the background to recognize what it means for the biology of the planet and how, in the end, that's pretty important to us as living things. So I think one of the other things that there's a lot of space for creativity is in the social sciences, and particularly in economics. Did I talk about the book Corporation 2020 at dinner last night? Well, it's an amazing book. It came out in June. It's the history of the corporation, how in 1919 it became only about short-term profit. Before that, you could have additional purposes. How it has grown to be 70% of the global economic product. How advertising has, on certain occasions, fanned the flames of corporate activity inappropriately. But there's no reason it couldn't fan it in good ways. So there's a whole sort of economic side of this, which is important. And then there's a piece which you don't get much attention paid to, which is how can we actually have a reasonable quality of life with less consumption per capita. And we did talk about this yesterday. I mean, the generation before mine, which had the experience of the Second World War and the Depression, no matter, what their financial status, emerged from all of that with a sense of frugality. And that, I think, needs to return. And what I'm saying is it's not that you don't use things, but you use them with much more respect and frugality. And so the example I gave is, aluminum foil is invented. Everybody thinks it's this wonderful new thing. But how did it get used? Not the way it's used today. People would use it, wash it, reuse it, wash it, reuse it, wash it, until finally it fell apart. And I think we need to sort of regain that sense. And sometimes it's a matter of, the economics of it. But I think it's also part of having to recognize that we're basically in one big world now, all 7 billion of us, and it's all connected in ways that can work for us positively or negatively, depending how we pull the strings. Great.